with Exact Metrology. My email is mikeg@Exact Metrology. If you have any questions after the webinar, you feel free to email me if you have any more questions. I'm going to get started right now. I want to thank you and I for doing this again. What we're going to discuss today is we're going to kind of discuss Workspace. We're going to discuss proper techniques of scanning, how to hold the arm, how to scan holes, corners, cylinders, and we're going to kind of discuss a little bit about scanning plastics and shiny metal using developer spray also when you don't need it. So first I'm going to get started with discuss the workspace setup. For a proper scanning workspace, you want to have a clean area from any objects. You don't want to, while you're in the middle of scanning, bumping into objects and the objects falling and hitting your part. It makes for you having to either leapfrog or start your scan over again. So just make sure that you grab any arm. It doesn't matter what size. Right now I'm using an RA7525 SEI roamer arm, just a basic arm. What you want to make sure is that you grab your scanner, move it around the workspace, make sure that you're clear of any obstacles in a circular motion around the whole part. You need to make sure that you have a proper base for your scanning. You need to make sure it's stable and will not move. I had a situation where I was scanning, the data was not coming good, and I found that my lock on the bottom of the base was not properly locked, and so in turn, the scanning data was jagged and moving, so you want to always make sure that that's proper. It will show some wavy data, and you'll see that when you get that. You also want to make sure that your arm is secured to the table that you're on, that the table is not moving or has any vibration. That vibration will show up in your scans also. The proper height of the arm, you want to make sure that you have a proper height to the part you're working on. You don't want the base of the arm to be way low and then you're scanning way high above your part. You'll have a problem with the angle of the arm reaching around and over the part. The second option that we need to discuss is will you need to leapfrog due to the size of the part? You need to know if your part's too large. If it's too large, you need to know how many leapfrogs you're going to need or how many moves you're going to move the part around the scanner. It's important to get as much coverage in the first scan, as that will be your reference scan to leapfrog to all your other scans. And what I mean by that is when we have multiple scans you could have 20 scans. The first scan, we want a large majority of the part. We want to make sure that we cover, a good percent. And then every scan will be locked into that reference scan, the first scan we did. And each one will tie into that so that they will link up very well and be aligned very well. You do want to ensure that your scanner will hit all areas that you want. Mostly you want to grab features that you're going to leapfrog to. So when I mean that was when we tie point-to-point data alignments, you want to make sure that you have good coverage of areas that will predominantly be your featured point data so that you can leapfrog successfully. And I will show some of that later in the scans here. You want to take your scanner before you begin scanning. You do want to take your scanner. You want to move it around the part. You want to check that it's reaching areas that you want. You want to make sure it's covering all areas. I just grab the arm and just kind of fake motion around the part, move it up around and around and around, and sometimes under the part. This ensures that you have a proper setup before you're scanning. You don't want to go 2 hours into scanning and then find out you can't hit a certain area. The more overlap data you get, the faster and better the data will be when you do your data to data fit, and I'll show that later in this webinar. So proper setup of the scanner, I'm going to discuss a little bit about that. So give me a minute here. I'm going to pull up another screen here. Everybody see that all right? So in this lower scan, this is a proper setup of our scan. This is our scanner here in the middle. And we do want the scanner, if I am standing here, I'm going to kind of show a little shape of me. This is me down here. And what I do want is the arm to be away from me. And this blue square is my part. And I want the motion of the arm to be this outer circle. So if you can see this circle, I'm able to move around this part successfully and capture all areas of the part that I need. An improper setup is one like this, where you can see here's the scanner, and I'm going to insert me into the picture. I'm right here. As you can see, the scanner is only capturing a small portion of the part, which means that I would have to leapfrog over to this corner to scan that much, and then probably leapfrog again to scan here. So setting up your part successfully in the first part, like this, with the scanner away from you, able to capture all the part, is the proper setup. I've seen some where they've had it down here in the corner, and then they have to move the part 3-4 times to successfully scan the part. So I do want to iterate that this is really important, as the more scan data you collect and more you collect, the more data you're going to have and the slower your computer will be in time. So just remember that this is probably the most accurate technique that you can have for setting up. Everybody, can you see that all right?
Yeah, we can.
Okay. I wasn't sure. All right. We'll go back to this. All right. The next thing I want to jump into is when to properly use developer spray on plastic or shiny metal, and when not to. I've dealt with a lot of plastic in my days. I did 6 years of scanning plastic, so I'm primarily really knowledgeable in plastic. I'm getting familiar with doing metal more. Metal's a little easier to work with than plastic. So I'll have a diagram here to show you what kind of happens when you scan plastic. So I have 2 diagrams here. The top one is scanning plastic with no developer spray. Certain plastics, whether it be transparent, light colored, yellow, light gray, I've dealt with many colors. What happens is the scanner is this middle line, and as you can see, the scanner will shoot through layers of plastic, and the plastic is actually it's crystallized, and it'll start to shine through the layers of the plastic and bounce off the crystals in many directions. And so you get this very large laser that's kind of fading out as you're scanning. And what that will do is it'll start giving you noise. It'll start shooting inside the part, outside the part. You'll have noise inside and out, and you'll get an inaccurate scan. When you do scan with developer spray, it'll limit that, as you can see in the secondary scan here. And what that does is it covers, it's kind of a powder. You can get it at any welding shop. It's kind of a crack check spray. That's what I use, called DNF developer spray. You could also use, I've seen guys use foot powder. They've used that many years in the past. It's kind of a cheaper way of going about it. What it does is it puts a fine powdery layer on the part, and then that layer will cover the plastic, and then it will not shine through into the crystals of the plastic. Oop. Sorry, I lost my screen there, did I? So I'm going to show you what a scan test on plastic is. So I'm going to open up this scan test that I did today. So the first scan that I did, as you can see here, was scanned with no plastic or with no developer spray. As you can see, as I zoom in, you can see where the plastic is creating noise on the outside of the part here. I'm going to turn up these pixel sizes. So you can see it's hitting in the part, bouncing outside, creating a lot of noise. You're starting to get jagged edges right here. And it's data that we're not really wanting. If we were to measure certain surface profiles of this cap, it would pick up these pixels and it would give us inaccurate data. This cap was yellow. It's I just used an Armor All lid that was sitting around the house. Then I went outside and took the same lid and I scanned it with developer spray. It took about 2 minutes. And as you can see, compared to the other data, the areas that we were having difficulty with the bouncing and the reflectiveness of the part, we now do not have any noise on the outside edge. So you really want to look for, is my laser transparently shooting through the part or not? If it is, this is a good indication that you need to use developer spray. Another way of possibly getting rid of that noise is to check the intensity of your laser, which is in your RDS. And I'll show that here. And in your scanner settings, right now I was scanning with 30%. This changes your exposure time. You can switch between different modes. Right now I have capture, so I can grab the arm, the 2 buttons on the side. I point that laser at the part. I press the 2 buttons on the side, and it'll beep, and then it starts registering the exposure time on that particular part. After it captures that, it gives me another beep. You'll see the intensity of the laser go high and low. And sometimes that will just be all that you need. If that does not work, you'll have to really go for the developer spray. The next that I'm going to show is metal. When you get into shiny metal, this top representation is scanning a metal part, no developer spray. It's very shiny aluminum, let's say. And as you can see, my scan is shooting down here, and as it hits the metal, it's refracting off into different directions. What that is doing is as it's hitting the part, the laser's not knowing which direction to shoot back to the scanner, and it's creating lots of different scans in different directions. What that will do is also cause noise and bounce off and create noise just like we did in the plastic. With developer spray, as you can see, as we shine back to the part, the laser has enough time to shoot directly back to the scanner, and it will give you your good data. So in both instances, you need to make sure that you understand and know what product you're working with and what particular metal or plastic you're working with to know if you really need to use developer spray or if you need to adjust your exposure time settings on your arm. All right. Now we're going to get into the proper handling of the scanner, where to hold, where not to hold. We really encourage to use the holders that are on the scanner. There's usually one on the elbow of the scanner and also on the arms of the scanner. They're little plastic areas that are freely movable and spinnable. We ask you to hold those. You definitely do not want to hold the scanner on any of the encoders or on the actual head of the scanner, as you could cause some issues with your scanning. So please just use the areas that were given to you to scan with. Now I'd like to talk in discussion with, it's not working again. We're going to discuss how to properly scan a part. It's not working. Give me a minute here. My scroll bar is not working. All right.
Mike, I have a question before you move on.
Sure.
Do you have recommendations for cleaning developer off the plastic parts when you're done?
I just use water.
Okay.
Just water and a brush. The developer spray that I use is recommended that you wear plastic gloves when you're cleaning. But yeah, water, soap, it comes right off. It's washable. It's just you don't want to get it in contact with your own skin, as far as with when it's in water. So, and if anybody needs to know what that spray is that I use, they can email me and I can send them a link for where they can get it. All right. So now we're going to discuss a fluid motion of scanning, how to properly scan the part. As you can see in this image here, a good motion of scanning is a side-to-side motion. We do not want to scan sliding up and down. And I'm going to show you why. Get a new screen here. Lots of screens. I'm sorry, guys. Everybody see that?
Yep.
So as I'm scanning, and I have a part right here in front of me, we want the motion of our scan to go side to side. So as I'm scanning, I'm going through the part. I'm at the edge of the part. I'm going to scan right back through the part. We just want a back and forth paint motion of the part, like so. We do not want to give a up and down motion or a side to side motion. Now I'm going to pretty much do the same scan, but I'm going to kind of rotate my wrist up and down and scan, and you'll see as I scan up and down, we start to miss data. So you can see as we're scanning, you really want a good paintbrush motion across the part, as it'll capture as much data as you need. I've pretty much got a large majority of this part in the first scan, and we're going to have to scan quite a bit if we were to do that motion on this one. And also, as you can see here, I'm going to zoom in a little bit. As you go up and down with the scanner, you can see that it's starting to create ripples in our scan. I've done this many years, and it's really hard for me to even get those anymore. But you can see we have one there. And it'll cause some inconsistency. There's a really good one right there. You can see the inconsistencies in the surface as far as how not to put the laser in and how not to drag the laser with up and horizontal with it. You really want to go across the part with the laser covering across the part in the side-to-side motion. And we can kind of see how smooth my skin is here. There's not really any vibrations. We got a little bit here, but that's because the laser is starting to fade off on the ends. So I've stopped about right here. I could have finished and it would fix that. If I came on the back side of the part, it would fix that. So really just maintain a very good side-to-side motion. Right here. Don't go up and down. Now we're going to talk about how to properly scan an inner hole and the motion. When we discuss holes, this could be holes, the top of caps, the top of cylinders. We really want to create a rotational motion of this. We do not want to scan straight side-to-side motion. And I'm going to show a little of that. I have a demonstration here that I did. All right. I'm going to turn that off for a minute. So this was a scan I did yesterday. I cut off all the other excess so we can just look at the hole. As you can see, there's very little ripples. These little ones that you see is just the pixels of the actual scan. It's just polygons. So I did a bad scan. And as you can see, the scan here, what I did was I took my scanner and I took my hole and I went down the hole in a downward motion like so. Just like that. Now Polyworks has a built-in plugin for a surface to normal angle. That is this blue area. What's that meaning is that the scanner is at such an angle that the software is trying to interpret the surface, but we are beyond our scope of 55 degrees, that the scanner is suggesting that we rescan the surface to make sure that we are accurately capturing the data there. The other is the curvature. It's low scan density for mesh curvature. So what is essentially, it's trying to build this curvature, but it's not sure because we were coming down at a direct angle onto this surface, that it's not sure if the angle, where the angle is and the curvature of that curve is. The proper technique that I'm discussing is to, we'll hide that one, is to take your hole and you shoot the laser in a curvature motion, at least a 55-degree angle. Oh, sorry. Yeah. Like so. And all I'm doing is sweeping, motioning, and it's showing me the blue is a little high on my angle, so I just brought my arm up just a little bit more. Now you can see I've got the right angle, and I'm starting to sweep motion around the hole. Like so. And as you can see, with a little bit of practice, a little bit of time, I have a little bit of areas that I need to finish. Just need to probably rescan one pass right here in the curve, and I can cover most of the part with the software. Hardly suggesting anywhere to fix or rescan. And you can see the clear data there. This is with proper scanning. And here's the data without. And you can see the different ripples that are in this on these areas. You can see the density of areas. And what you come up with is what I have here. This is a scan that I did earlier today on that same pass. And this is the color mapping. And as you can see, I have a few areas that are just at 5 thou. I have 2 thou. But we're pretty close to the surface as much as possible. When I match a bad scan to the surface, you can see how we're starting to get a lot of air inside. I've got 5 thou, 8 thou, 4 thou. I've even hit as far as up to 8 thou in these areas. So as you can see from the data, doing a rotational motion, if you're trying to get a couple thou more out of your scanner, rotating through the actual cylinder at a right angle will give you the better scan of a hole. Does anybody have any questions on that?
This is Lee. I have a question. So is this going to apply if you had like a cylinder as well? Would you go around the cylinder on the outside in the circular rotation?
Yes.
Okay.
Yes. I'll grab a cylinder here for you. So I'm going to do the good pass first on the cylinder. So as I'm directly out of radius on the cylinder. I'm going to kind of scroll around the top of it like this. So you can see right there, I captured the smooth data there. And you can do that just all the way around. When you get to the sides of a cylinder, we're going to discuss that. But as far as the top corner edge of a cylinder, you want to do that motion. And now I'm going to show how if we go down, a downward motion, we're just going to go up and down. As you can see, the upward down motion didn't capture anything on top. And the arm had just finding that right angle to capture the data is just not there. So you'd have to take more scans really to get acceptable data. So I went to the top, and as you can see, the noise, this is the same part. So no noise, very smooth inside this, and it's very, maybe a millimeter or two hole there. We're getting very smooth data there. And as you scan up and down, you can see it's very jagged. There's some noise sticking up all the way through. We don't need that. We don't want that. We want very smooth data, very smooth lines, always. And here's kind of a picture of the noise. Can you see that all right? Or do I need to bump these up? So you can see all the noise that's running around. in our scan. Whereas if we zoom in, there's no noise there. We can see a smooth edge in that one. So it is necessary when you're doing corners also to do that. And I have a corner check here that we're going to do in a bit. Does anybody have any questions on holes? All right. I'm going to go back to our page here. So the next scanning technique that I'd like to discuss is any corners or edges. As you can see, I have an image here. We want to go with this being the corner edge. We want to go with the edge in a sideways motion. This is our scanner. So we're going to kind of go like this on these corners, and then we would go like this on our corners. You do not want to go on the edge and scan like this. And I'm going to pull up a corner scan. Give it a minute here to load up. All right. So we're measuring corners or edges. We really want to define our corner. We want to get it in the proper 55-degree angle that I have on my scanner set up. And we want to go in a side-to-side motion, covering both sides of the corner. Sorry if that's small. Like so. Just like that. And we do not want to scan in a up and down motion. Like so. As you can see, we're getting some curvature errors on that scan. We're getting some surface errors here as far as knowing if it's the right angle that the scan is. And when I scanned the proper way, you can see we have a little bit on top. I can just do maybe one more pass. It would fix this area. And I could do another pass here in the corner to fix this area. And maybe a radius scan pass to fix this area right here. And then we would be done. So it would probably take another 4 or 5 in the bad scan and maybe 1 or 2 possible to fix the good scan. And then I'm going to show you some examples that I have set up. The first one, I'm going to show the corner bad scan. I'm going to show you the color graph of that. So as you can see here, we got some areas that are sitting about 6 thou, 5 thou, even some that are hitting +5 going -5. So we're looking at 10 thou overall error in our scan. And then the next one I'm going to show is a good scan in the corner. And as you can see in the good scan, the area that we were hitting 5, we are now hitting 1 to 2 thou in those areas. So we're looking pretty good. I would be very comfortable with a scan like this. Does anybody have any questions for corner scans? All right. So the next technique I want to use is when scanning outer curvatures. We kind of discussed that. Scanning in the outer curvature of a cylinder, you want to go at the proper angle, like so, and then scan in a circular motion, like so. Once you do the top, we will move our scanner like so, and we will scan down the actual cylinder and then back up the cylinder, or you could just scan down and down, whichever you prefer. I usually just go up and down like so. Some of the bad techniques that I've seen is I've seen people scan along the radius like so. This is incorrect. As your scanner starts to hit this edge, you'll start to get noise shooting up and down off the side of the part. And I'm going to show an example of that. Give me 1 second here. See that all right? So with this cylinder, on the curvature, like I said, we're gonna scan the edge of the curvature first on the cylinder, whether it be a sharp edge or a soft edge, or a radius edge like so. And then we want to scan up and down the radius edge. This will give us smooth data. We have some curvatures in there. I don't have any developer spray in those areas, but as you can see, the actual radius areas are fairly smooth. We're not getting a lot of breakup in the scan data. I don't see any noise. The improper way, which I'll show now, doing a side-to-side motion. We'll start to get tearing on the edge of the part. You have to scan a lot more to make your passes. So as you can see here, here's a ripple. So we're starting to get some ripple effects. It's kind of hard probably to see on my screen, on yours. When we look at the final mesh, you can see how we have a ripple there. That's 2 scan passes trying to connect. It's trying to build the mesh, but it doesn't know if it's in or out. We have multiples here, as you can see there. And here's another one, and another one. And we're just trying to deviate that ripple effect, as these data points will clump, and then you have more data that you need. This will cause a little bit of error. It might cause a wrinkle in your scan, and then if you're doing a surface profile, that wrinkle, if it be 3 thou tolerance on a surface profile, it might not pass in that area. Whereas you can see, most of my data is very clear. I have a large amount of data here, but that's because there is a actual curvature feature there. I don't have too many rips and tears in the scan. I have a little bit right here. Once I overpass that, it would correct it. But it's fairly smooth and not too many multiple scan overpasses like there. So there's clean, there's not clean.
So Mike, if you have a bad pass, can you just go ahead and scan over it again, and will it correct itself?
Would you like me to, I'll scan the bad one, and I can show you what that looks like.
Okay.
So, I'll scan, so we made some multiple bad scan passes. Now I'm going to scan over that area using the proper way. Right here, right? So as you can see, the software is smart enough to know, but we still have multiple scans on top of one another. It doesn't know when you stop and start. As far as Polyworks, because Polyworks does have a play scan feature involved with it, so it knows when you scan and when you're not scanning. If I converted this polygonal model, these would show up as polygonal models. So when you're doing if you have anything that has to do with your polygonal model, all these features will be little small polygons, and it would be a lot of data. Whereas right here I have just a very small amount of it, and here I have a large amount of it. It just keeps overlapping because it's not knowing where the good data and bad data was, because we scanned 2 different styles. You can kind of see where this was my good pass on top of my bad pass. And so you can see the bad pass below it. And it might be under 1 thou, but when we're trying to capture the best data possible, we want to eliminate as much noise as possible and have really good data right off the bat. Make sense?
Yeah.
Okay. So if we were to...
So one more question along those lines. Are you trying to do it in the least amount of passes as possible then, so you don't have overlapping data?
Yeah. You don't want to continuously overlap data to data. You could get noise.
Mm-hmm.
You could maybe maybe the light shines on a certain area and it reflects off, and you didn't do any developer spray, and it gives you a lot of noise. So if you properly scan it, it might not give you that. If the part's a little shiny, maybe not, and the light's shining on it, it could give you a lot of noise if you're going around the radius of the part, whereas if you're going with the radius. So it would shine down as you're scanning here, it might reflect off, and it might give you noise on the backside. Don't know if I have any on the edge. This part is kind of sprayed, so I don't see any. That was my good scan right here. Yeah, I don't really have. You can see some right here. So, but you can see how smooth my data looks right here. It's very smooth. The data is lined up. If I converted that into a mesh, these would convert very well into a mesh. Very good very good polygons. Whereas here, I would have good data here. Then I would collect a large amount of polygons there. And when you're trying to limit the amount of polygons, you're going to double your polygon data. And then that part that would have been, half a gig size would now be a gig size. And then you're looking at having to transfer that or having to convert it down, and then you're losing more data. So it's just a matter of capturing best data amount possible without creating a very large file size. And then also not creating noise and not creating bad data, as I showed you in the color mappings that we did in the other projects. Does that make sense?
Yeah, thanks.
Okay. All right, we're going to move on next. All right, now we're going to show you how I would scan a whole project. I have a demo play here, so I'm just going to use all these techniques to properly scan it. I kind of have a diagram here that I have. In this diagram, this is our scanner. So a good proper technique is, I don't have any features in the middle, so we're just going to say it's a square block. The proper scanning technique is we're going to scan the edge like so. And this is the corner. And once I get to this edge, I'd rotate my scanner, scan down, get the other edge, rotate again. We're going to move along this edge. We're going to rotate, and then we're going to scan this way. So that locks out all of our very hard features, our edges, our corners, our radiuses. And if I had, a hole in the middle, like so, we'll give it then I would come over here, I would scan. Scan in a radius around this to get the edges. And then once I'm done with that, we would then start to scan a back and forth motion on the part. And you can have your scanner just a little bit angled so that it kind of shoots elongating across the part. You don't want to go too much, but just kind of like so. Then I would come here, scan like this, scan like this, scan like this. And then I would go back to my hole and then do my inside rotational scan like so. I'm going to show you that now. All right. So I have a demo block here. It's fairly large. It won't take very long to scan, but so I'm going to scan. I'll start on my proper color matching to it. I'm just going to kind of scan the edges. radius right here. As you can see, I don't have any blue on the top and I don't have blue on any side, so I'm at a proper angle. I'm going to curve around this curvature here. Continue around the front side. Continue on the outer edges. Make sure that I have all data that I want. A little bit off on this. This is the back side. So I'm going to reshoot this area first. Proper angle. Now the data that you're seeing here on the bottom of the part, that's my table. It's just my kitchen countertop, so it's kind of very reflective, so you can see it's not collecting data there very well. Now I'm going to grab inner features. I'm doing a slot right now. We're just going to sweep around these radiuses as much as I can. I have a cone here. I'm just going to sweep around the edge of the cone. As you can see, here's my slot. I have a little bit inside the scan. Here's my cone. You can see I just have the bottom feature to scan. My edges are looking pretty good. I have a little bit of data to fix there, but overall I'm happy with it. I have a little bit right here. Gonna fix these areas. Now I'll move on to this feature here. I'm going to sweep around this radius. Finish that feature. Yeah, I got a little high angle on that edge, so I'll just angle up a little higher. Get to that bottom floor. And I need a little bit inside more. So now for that wall, I angled down onto that wall, so I'm a little bit more direct to that wall surface. Let's fix that wall there. The sphere, I pretty much just kind of go around in a radius like so, starting from the bottom working my way up. I have a little bit on top. We'll just get a little higher. Like so. A little bit there, but I'm okay with that. Then we move on to the hole, which I have right here. Try to catch the proper angle. I'll take my first pass. Look to see that I'm covering it right. Looks like I'm at the right angle. Now I can just continue to scan inside. And then all we have left is this cylinder here. So cylinder acts, or the cone just acts like the cylinder. We're going to shoot just down the feature as much as we can. Try and get an angle here so you can see. Now we're going to scan across the top of the part. And get that corner first, then we're going to scan. Side to side. Like so. Then when I'm done with my scan, there you go. We have a little bit right here. This part is metal. There's a little bit of paint chipping off and the shiny metal's coming through. I would probably delete this scan here. Like so. Rescan that area just to make sure that I use proper technique. Sorry, so that is a misalignment. It's probably for me walking on my floor. I'm on a wood floor in my office. So you can't get that every once in a while. Just delete that pass. What that means is the previous scan you had is not matching the scans that you are working on. So it is past my tolerance limit that I've set in the software. And it tells me I should delete that, rescan the area, Might have put my countertop here. So as you can see, we eliminated that edge now. And the same applies to holes. You can see we have most of our holes are already collected. We don't have to really go in and scan them. We pretty much grabbed as much data as we could in them. We'd have to get, you know, like this hole, we'd have to just scan a pass on the top. This hole, we would just probably one scan here. This hole looks like we just need to do one pass right here. But overall, in a very short period of time, we collected, how many data points? I think I had like 30 million in a very short period of time, and we have a good part here.
Mike, could you take a step back and show us how you deleted a portion of your scan?
Yeah. So here's a bad corner right here. So in Polyworks, which is the software that we're using, I do believe you guys have that too.
Yeah.
You want to hit your space bar, and then you have the option of paintbrushes or selection of contour or selection of polygonal. So I can show you a few. So the paintbrush is just a paintbrush. I'm mouse wheeling up and down. You can select it like that, or you can drag wherever you want to delete. And you want to make sure that you have this volumetric turned on right here. If you don't, when you delete, it won't delete the actual surface. You need to grab the volumetric, and then it deletes the volume that's in there. The other options are the contour. So it's just, you draw what you want, it selects, you hit your delete key. Another is polygonal. You just polygonally draw where you want, and then delete there. And then if you, let's say you paintbrush an area and you're like, oh, I grabbed too much, or you kind of grab the feature you don't want, you can just hit this none button here, and that'll erase it. So if I want this corner here, I can hit delete. I can undo that if I want. I can undo all the ones I've done by hitting this undo button there. You can also invert your selection. So if you grab this corner here, I want to invert, you can grab everything but that corner. So if I'm just solely working on this sphere, I can go in and grab my sphere, my ball tool here, and just go in and select the whole ball. Invert, hit delete. Oh, it's not going to delete today. You can invert it like so. And I need to, I believe it's that one. Like so. And then now you just have your sphere.
Okay, so you were kind of using a selection tool and then just using the delete key to delete those. Like,
yep. Yeah, I was just using delete. Yeah. So you can pretty much anything you've scanned, and you can do it while you're scanning. So if I have my scan open, I primarily do it when I'm scanning. So while I have my scanning open, and we'll convert it here. So as I'm scanning, I can come in and I can see the back face here, so I can see I got a little bit of bad data there. So I would just go in, select this corner, delete that corner, and then come back in and reshoot that corner.
Okay.
So I can reshoot it here. I moved my part. so I would just rescan that corner. And then that would be all you need to do. Okay?
Yeah, thanks.
Yep. So does anybody have any questions on, scanning features and then properly scanning it? So primarily, I really work on the outside and cover as much. You see, I covered probably 70% of the part just scanning just the outer edges, and then I went in and just rescanned my features. Tried to cover as much as I can. While I was scanning here, it was collecting data over here, and after a certain point, you kind of start to feel the motion that you're moving. You want a very fluid motion. You want to kind of continuously work organic with what part you're working on. These holes here are very hard. Scanning up and down, getting in these cylinders is just really hard to get in. The scanners aren't made to get in very deep holes. I can get the edges. I can get quite a bit in. I mean, you can see right there, I've gotten quite a bit distance inside. If you're collecting, very inside deep data, it's going to take a little bit more time to go in, get in these, get them refined. I did this one really fast, so I have some really bad data here that I would have to get rid of on some edges. But overall, once you know what to look for, these are kind of noise and tears. You can see. Try and zoom in there. Get in there close enough. So you can kind of see the noise. They're a different color here. They're kind of bouncing off the part. It's just because the part edges are shiny metal and I didn't use developer spray, the laser is shooting down. It's hitting this really sharp edge that's there. And because it's really shiny, it's kind of reflecting off a little bit. When I did my scan pass on the top, it probably came in, reflected out right here. So that's why you want to be kind of, in a line across this corner first. And the same as here. It's shiny metal right now that I'm using, and I should have probably sprayed it before we did this, but. That's all I have for proper scanning techniques. Is there maybe we can do some questions if anybody has any questions on anything. I can kind of show them if they have a difficulty with certain scan passes on certain areas. We can kind of leave it open for that now. Looks like we don't have any. All right, well, that's all I have for today. Not sure if you have any other questions for me or.
I don't. I appreciate you sharing with us today, Mike. I know I found quite a few things that I was doing wrong, so I appreciate these tips and tricks.
Yeah, and once you feel, that you've kind of got that. Okay, this is how I should do a cylinder. This is how you'll start to see how your data becomes less sizable. So they're not as large. You're not collecting as much data. You're not getting as much noise. You're not having to delete or restart as much. And the developer spray. Let me see if I can find that really quick. 1 second here. Sorry, I'm trying to share my screen here. So this is, can you see that?
Yeah.
All right, this is what I use. Right now it looks like it's 14 a bottle. It's Dynaflux crack check. It's a DF. I use a DNF. This is the DF developer spray, but you do want the ENF developer spray. I get that. What is it? S&J Smith. The welder. Then in Iowa, that would be a predominant location that I would pick it up at. It's usually 9 to 10, 12 a bottle. But like I've seen some gentlemen that I've seen use foot powder. They use just your average foot powder, and you know it's a little bit cheaper, and they put that on the part also. So that's primarily what I use. I've used that for 6 years. I've liked it. It coats the part really well. You don't have to spray like a paint can where you have to really, you just one light spray and it'll cover the area that you're doing. I kind of put my webcam on and show you what it looks like on this. So as you can see here, this is a cap that was sprayed. It's just a lightly coat, and this is what the cap looked like before. So I just lightly coat it, and it does come off like so. But when you mix it with water, they suggest that you wear gloves when you do that. So that's all I have today. If anybody has any other questions, I'm more than welcome to answer them. All right, well, I appreciate you and Zach let me do this webinar today for you guys. I hope everything helps you. Feel free to email me. It's mikeg@exactmetrology.com. I'm more than welcome to answer any questions anybody has after the webinar.
All right. Thanks for your help today.
Yep, thank you. Have a good day.
You too.